All right, so here's the proof that I said was similar to first hours, but with one slight variation. And I'll tell you the variation was we only have one, E is only the midpoint of one segment, not both. And that changes the proof fundamentally. So if you review this tonight online, make sure you get the one that matches what you guys had. Or if you don't, be aware that they're very, very similar, but still different because I changed the givens up. So before I start writing the proof, the first thing I'm going to do is take a look to see what will happen when I mark my knowns over here on the diagram. Now the parallel is already marked. Midpoint tells me what? It's the center point. So how do AE and EC compare to each other? They're equal, congruent. So we mark that. Forget everything else for a second. I'm working with two triangles. That's triangle ABE. That's this top guy. And if I'm not sure, maybe it helps to use my colored pencils or pens or different shadings to kind of mark in what it is I'm really working with, to help me visualize where I want to focus my attention. These two triangles are formed by lines that cross. So what does that tell me? Vertical angles. I don't know if it's going to be part of the proof or not, but I'm going to go ahead and mark those as congruent angles because it's true. It's something I can very easily prove. It's a straightforward theorem, and it might come in handy. Now for this one, the hump has to do with bringing this parallel in. We haven't used that fact yet to talk about anything. Well, if I've got two parallel lines, and they're cut by a transversal, does that tell me anything? Got to think back a chapter. D-A-E?
I mean, E-A.
E-A-B. So, that guy. Right. I'm going to go ahead and I'm going to blacken in the first of those arcs so you can really see the angles we're referring to. So we've got those angles. I've got these angles. I've got that side and that side. Do I have enough facts now on my picture to prove I've got two congruent triangles? Yeah, I've got two angles and the side between them. Now, the trick to this is one, you can also do it by using these angles and then the third angle theorem to set this up, or just these angles and angle, side. So that's an option. You also want to remember that the vertical angle, that's not even mentioned in the givens, but part of the challenge to these is to be constantly asking yourself, what are some generic things I always can show based on the diagram? Vertical angles are on that list. Reflexive segments are on that list. If they ever share a side, reflexive property tells me that they're going to be congruent between the two shapes. I should write that down. I should mark it, and I should be looking for that checklist. Once I've got that, I've got my proof done. All I got to do now is sit down and actually write the essay. I did the outline. I did the brainstorming. Now let's write it. I got my givens. AB is parallel to CD. And before I write my other given, let's write the implication of that, which is that angle BAE, which is the same as EAB, is congruent to DCE because they're alternate interior angles. My other given was that E is the midpoint OAC, and that led me to AE congruent to EC by definition of midpoint. Lastly, angle AEB is congruent to angle DEC because they're vertical. And I wrap this sucker up by saying triangle ABE congruent to triangle CDE by angle, side, angle. And that is what I set out to prove. What can I say about that? I think I'm going to look it over. We'll see what kind of questions we can ask.